Hello and welcome to this video on solving problems, specifically kinematics problems using equations.
A sample problem could be something like a remote-controlled car is driven along a straight track at 2 meters per second. The child controlling the car activates the turbo mode so that 3 seconds later the car's velocity is 3.2 meters per second. Find its acceleration. Now we've been doing this graphically, but let's talk about how we do it via equation. I'm a big believer in the go-guess method of solving. That doesn't mean plug in random numbers. That is a mnemonic. We start with the Go. Go is a graphic organizer. This could be a graph, this could be a free body diagram for forces. In this particular case, it means we're going to draw a graph. So it's going from here to here on a velocity time graph, like so. The next G stands for givens. What numbers or facts does the problem give you?
It's useful not only to know what the numbers are,
What type of thing they're measuring. In this case, the 3 seconds, for instance, is going to be a time. The 2 meters per second and the 3.2 meters per second are both going to be velocity. Now, how do I know this? Well, the easiest way to know things or find things out is to look at the units. We measure time in seconds. So whenever you see seconds, you should be thinking time. Whenever you see meters per second, that should be a velocity. Meters per second squared, an acceleration. Displacement's typically going to be in meters. The problem here is we have two different velocities, so we need to distinguish what type of velocity we're talking about. The car is being driven at 2 meters per second, then they accelerate, then it's 3.2. So at the start, it's going to be 2. So we're going to use the little naught symbol, or initial if you prefer, to indicate this is the initial velocity. Now we've identified our givens. Now we need to find our unknown. What am I looking for? What is the problem asking me to solve? And typically it's going to be something like how far, how long, what is. And in this case, it's find its. It's explicitly spelled out for you. Find its acceleration. That is my unknown. Once you have your unknown, find an equation that ties these 4 variables together. That's going to be your E. So, which equation? We only have 3 options here. Equation 1, equation 2, or equation 3. Equation 3 doesn't work because we don't have displacement anywhere. Same thing with equation 2. There's no mention of position at all. Leaving me with equation 1, V equals V naught plus AT. We have V, V naught, A, and T. Seems like a good spot to be. So my equation is V equals V naught plus AT. Once you have your equation, the order you do your S's in fluctuates. I personally will always solve for my variable. So in this case, I'd solve for acceleration and then substitute in my numbers. Other people will say you substitute in your numbers, then solve. I'm going to branch this out in one of 2 ways. So in black, I'll do substitute, then solve. In red, I'll solve, then substitute. Let's start with black. Substitute, then solve. So plug in your numbers. My final velocity is 3.2. My initial velocity is 2. My acceleration is my unknown, so I leave it as A, and then I plug in 3. If I solve for this, I subtract 2 from both sides, I get 1.2 equals, I'm just going to rearrange this to say 3A. Divide both sides by 3. A equals 1.2 divided by 3 is 0.4 meters per second squared. This is substitute, then solve. If you get into higher level math or higher level physics, typically you want to rearrange the equation first. One, this means that you don't make any rounding errors or mistakes. And two, it helps you give a better sense of how the variables relate. So to substitute, then solve. To substitute, then solve, what you need to do is you need to get the variable you're solving for, in this case a, your unknown, to the all by itself. So to do that, I'm going to subtract the v naught to the other side, and then I'm going to divide both sides by t. And then I substitute in my numbers. Plug it in your calculator all at once, and you'll still get the 0.4 meters per second squared. Either way you go about this, it works out. The question is, what are you more comfortable with? I personally would encourage doing this as much as possible. It helps develop your algebra skills. It's more useful for higher level math. But a lot of people don't have the number familiarity or comfort, and they'll end up doing this. That's okay. Let's just fill in our last two steps here. Substitute, solve. And that's how we're going to solve pretty much every single physics problem all year. We're going to make a graphical organizer. We're going to find our givens. We're going to find our unknowns, find an equation, substitute, solve. And that's it. Let's do one on your own. Okay, so here we've got a problem we've already done graphically, but now we're going to try to do it using an equation. A car is initially moving at 10 meters per second and accelerates at a constant rate of 2 meters per second squared for 4 seconds in a straight line. How far did the car travel during that time? Go ahead and give it a try on your own, then check back after the pause. Okay, so I'm going to go through this entire problem starting from the top. First thing I want to do is draw a picture of what's going on. So we can do that. We can do that up here. So graphic organizer. Starting at 10 meters per second, it's accelerating, which means it's going to move up for 4 seconds, which means we want this area. And again, notice how my drawing isn't perfect. Yours just doesn't need to be either. So we want to find that area. So next thing we want to do is we want to go through find our givens. Any numbers you see, 10 meters per second, 2 meters per second squared, 4 seconds. The 10 meters per second is in a velocity. We know because it says meters per second, and it says initial, so that's probably my initial velocity. V naught equals 10 meters per second. 2 meters per second squared. The squared tells me it's an acceleration. And then the 4 seconds is a time. Secondly, I need to figure out what my unknown is. What am I looking for? How far is a good way to say displacement. So now I need to look for an equation that ties in initial velocity, acceleration, time, and displacement. I go look at my equation sheet, and there's nothing that has a displacement explicitly on there, but there is one that has x and x naught, which I can use. So in this case, x equals x naught plus v naught t plus 1/2 a t squared. Now the reason I know I can use this is because I have x and x naught, and if I had moved the x naught to the other side, x minus x naught equals delta x, which is displacement. The other thing you can always think about is if you know your starting position or it doesn't state a starting position, you can assume that this x initial is 0, at which point we know x0, v naught, t, a, and t. Substitute, I rearrange, solve for all my things, solve for my unknown, but my unknown is already solved for. It's already on one side of the equation. It's actually really convenient for us. So now I just need to plug in. Put the 0 in there that I implied just to be complete. 10 times 4, 10 from here, 4 from here, plus 1/2 times acceleration of 2 times 4, which is t squared. And when you go through this, remember your order of operations. Square first. 10 times 4 plus 1/2 times 2 times 16. Then multiply. 4 times 10 is 40. Half times 2 is 1, times 16 is 16. Add after that gives you 56, and because we're talking a distance or displacement, probably going to be in meters. The other way we know that is because this is in meters per second, this is in meters per second squared. Once I multiply by time, the seconds will cancel out, leaving me with meters. And there we go. The final thing I want to talk about is an extra equation. Now, one of the things that isn't on the AP test or isn't on any equation sheet for the AP exam, but I often give to both regulars and AP, is an equation that helps us find an area for a very specific scenario. And that's this scenario here. So if I were to draw this out, I could see how this goes fairly quickly. I'm starting from 4 meters per second. I'm ending at 14, which means an upward acceleration like this. And I want to find this area. Now, none of the equations we have directly relate these together. Let's go ahead and write those equations down. If we look at this, none of these equations directly relate together. More likely, none of them relate time, delta x, and two velocities. This one here has two velocities and time, but
Also,
no acceleration, which we don't know. This one has delta x, or x minus x naught, has initial velocity and time, but again, the acceleration. And same thing here, all of these require acceleration in some way. So the traditional way we would end up solving this is plug into one equation, find the acceleration, probably this one because it's the easiest, and then take that acceleration and plug it into another equation, again, probably this one, to make our lives easier. However, there's another way we can do it. The AP exam won't give this to anyone, but I insist on giving it to people. And there's another equation here. Because this is a trapezoid, we can use the area of a trapezoid formula, which is 1/2 times height times base 1 plus base 2. But instead of putting in the 1/2 and all that, we're going to put in our variables. So delta area, we've said many, many times, is displacement. The half is just a number. The height is the distance between these two parallel lines. It's this side here, which means it's time. Base 1 is this side, which means it's going to be your initial velocity, and then base 2 is going to be this side, which means it's going to be your final velocity. And this is, in essence, the average velocity formula. It only works for constant acceleration. Let's put that note here. Only works for constant acceleration. But it will give you a value. And as long as you're working with constant acceleration, which is the entirety of this unit and the AP class, it works. Just for reference, this is just a rearrangement of with the average being, because we have two velocities, we're averaging them together. This one will allow you to solve problems like this. If you are in AP and would like to use this on the AP exam, you will need to memorize it. If you don't want to memorize things, I don't blame you. Just go ahead and do a 1-2 step. Solve this one, then this one. But if you would like to solve this problem using equations, here's a fourth equation for you. A shorter or more common way you might see this is as such. It might look something like that. Either way works. Thanks for watching.